Good morning. Now we will discuss about multi-pressure system, that is unit number 2. In first unit we have discussed about basics of refrigeration, that is definition of refrigeration, unit of refrigeration. After that, reversed Carnot cycle, numericals on reversed Carnot cycle. After that, Bell-Coleman cycle, examples on Bell-Coleman cycle. After that, simple vapor compression cycle, numericals on simple vapor compression cycle. After that, different methods, that is different types of vapor compression cycles that depend upon the condition of refrigerant at inlet of compressor, outlet of compressor, inlet of condenser, outlet of condenser. That depends upon the condition of refrigerant. There are different types of vapor compression systems. Now in multi-pressure system, whatever we have discussed about simple vapor compression cycle, that is in previous chapter, that simple vapor compression cycle is a two pressure system. That is, two pressure means higher pressure, that is condenser pressure, and second is low pressure, that is evaporator pressure. That is, inside this system only two pressures are there, that is pressure in condenser and pressure in evaporator. Hence this system is called as two pressure system. Now multi pressure system means if pressure in the systems is more than two, that may be three pressure, that may be four pressure, that depend upon the requirement, then that systems are called as multi pressure system. The system with more than two pressures are called as multi pressure systems. Now the question is, why the multi pressure systems are necessary? Why there is a need of these multi pressure systems? If you have a two pressure system, that is if you have a compression system, vapor compression system, then why there is a need to increase the more pressures in the system? Now we know, or we remember the thermodynamics second year. In that thermodynamics there is one chapter, that is compressor. In this chapter we have discussed about the derivation of work of compression, that is compressor work. Okay, so if we increase the pressure ratio, and if this pressure ratio is exceeds, then compressor work increases. Compressor work increases means as the pressure ratio increases, temperature of air increases continuously and volumetric efficiency of compressor decreases. So to reduce this, if we reduce the compressor work, if we reduce the volumetric efficiency, automatically the coefficient of performance increases, because we know the formula of coefficient of performance. COP is always output divided by input. So in case of refrigeration, output is refrigeration effect and input is compressor work. So as the compressor work decreases, automatically the coefficient of performance increases. So with the help of single stage compression, if we increase the more pressure, then volumetric efficiency of compressor decreases and work which is required for the compression is more. So to reduce this compressor work, to increase the handling capacity of compressor, that is volumetric efficiency of compressor, instead of single stage compression, we have to always prefer the multi-stage compression. If we pressurize the refrigerant with the help of number of stages, that is low pressure stage, after that intermediate stage, after that high pressure stage, likewise, then what happens, the work which is required for the compression, that work decreases, volumetric efficiency of compressor continuously goes on increases, and due to that coefficient of performance increases. Hence when the pressure ratio between the condenser and evaporator is greater than 4 or 5, multi-stage or compound compression is desirable. With increase in pressure ratio, the volumetric efficiency of compressor decreases, and hence refrigeration capacity also reduces. Therefore, to reduce the work of compression and to increase the refrigeration capacity, a multi-stage compression with intercooling is one of the most effective method. If we see this pressure volume diagram, so in this diagram, if we compress the refrigerant with the help of single stage, then the process is 1 to 2 dash, and if we compress the refrigerant with the help of two stages, that is first one 1 to 2, after that there is intercooling 2 to 3, and after that again that refrigerant is compressed or pressurized with the help of second stage, that is 3 to 4. Then what happens, if you see the diagram, the area under the curve for the single stage compression is more, that is 1 2 dash pkps. So this is area under the curve for a single stage compression, and for two stage compression the area under the curve is 1 2 3 4 pkps1. So this is the area for two stage compression. So with the help of this multi-stage compression, that is two stage compression instead of single stage compression, this hatching area is nothing but the saving in the compressor work. So this much amount of compressor work decreases. As there is intercooling in between the stages, in a second stage the volumetric efficiency of compressor increases. Now how this volumetric efficiency increases? During the intercooling, the temperature of refrigerant decreases. As the temperature of refrigerant decreases, its volume reduces. As its volume reduces, the more amount of refrigerant gets compressed or pressurized with the help of single stage compression. That means refrigerant handling capacity of compressor increases, means volumetric efficiency of second stage compression increases. So as we increase this number of stages, then the volumetric efficiency continuously goes on, increases, and the area under the curve decreases continuously. That means compressor work reduces. As there are number of stages, we can reduce the compressor work. So with the help of this multi-stage compression, we can reduce the compressor work, and as the compressor work reduces, coefficient of performance increases. Now this multi-pressure system is essential for the large capacity applications like ice plants, because in this case large amount of refrigerant is circulated through the system. So in that case it is not possible with the help of single stage compression, because there is a large pressure ratio. As pressure ratio is more, we have to handle the more or large amount of refrigerant. So in that case these multi-stage compression systems or multi-pressure systems are used.